Hello, my name is Azrul. So now I would like to explain to you guys about the question 1b. So there are the question, there are give some statement. So let me read the statement first. A student learn how logical and arithmetic operations are performed at the assembly level using the Motorola 68K processor. The instructor has asked him to explain how basic logical instructions work in practice based on figure 1 below using Easy 68K simulator. So here the assembly language that we should uh, use it in Easy 68K simulator. So next we will see it. Here are the steps. And let me read the question first. So the question is to describe every steps of the assembly language of figure 1 using Easy 68K simulator. So here the Easy 68K simulator. First, I will change the ORG first from 1000 into 2000, and here the move until sub. Just copy from the question. After that, we will click the run one, and this will out. This will we can see this. If there is no error, you just can click the execute. If there's have a error, you must click the load one so that you can see which one the error. So after you click the execute, this will come out. This will come out, and here you can see the address memory register. You can see this. Actually, I want show you in a screen recorder, but my laptop just cannot record the whole thing, so I just screenshot this. And the next one, I will describe you guys about the step, instruction, and effect on the registers. So first, the step number one, like I say just now, the instruction org 2000. The description of this instruction, the set of program that start address at memory location 2000H. So effect on the register, program will begin at address 2000. Step number 2, the instruction is move word hashtag dollar for AB7 D1. The description of this instruction is move 16-bit value for AB7H into register D1. So the effect on the register will be D1 equal to hashtag dollar for AB7. Step number 3, the instruction is not word D1, and the description of this instruction is perform bit was not on D1. The effect on the register is D1 equal to not dollar for AB7 to dollar B548. Step number 4, the instruction is move word hashtag $5E92 D3, and the description of this instruction is move 16-bit value 5E92H into D3. The effect on the register of this instruction is D3 equal to hashtag $5E92. So will automatically stops. So that's the explanation for question 1. Now we go to the question 2. The question 2, list all logical and arithmetic instructions in M68K assembly language. So first, I will tell you guys about the logical instructions. So the instruction of logical instructions, there are 1, 2, 3, 4, 5, 6. There are 6 instructions, and those instructions have own function. For example, AND, the function is bitwise AND. For OR, the function of this instruction is bitwise OR. The instruction of NOT is logical bit inversion. And those three have their own function. So you can read it. The next one, arithmetic instructions. There are 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 instructions, and each of these instructions have own function. For example, ADD, the function is add. ADDA, the function is add to address. ADDQ, the function is add quick value. And those 1, 2, 3, 4, 5, 6, you can just read it. Now the question 2, I will. So now the question 2, I will pass it to my.
About the question 2. Okay, so the first, my question 2a is convert the expression below into an assembly language instruction. So the instruction given is a 10111111. This is the binary, and then multiply with dada. This is hexa, and then like plus with 1 2 3 4. This is octal. So what we're going to do, let me proceed to next. So the first thing after we having this of the instruction, so the first we need to convert the binary into the hexa. So after that, we also convert the octal into hexa as well. So we can to perform the multiplication and the addition. So this is my coding for the easy 68K. So as you can see, here will be the title only, is not important at all. So here is the original is 1000, and then start. Now here is my coding. So the first is move.w, placing this 00BF is the convert of the binary to hexa. So the BF is here. On the blue side is the comment of the coding. So here the BF was convert, and then so we are moving this data into the D0. So the first thing we need to do is loading the data into the file. So the second line also, move.w, that means that moving words, the moving things would be the DADA, so it will be moved into the D1 as well. So next is the mulu. This here will be perform the multiplication, which is using the D0 to multiply the D1. So after it multiplied, the data will be stored in the D1. So after we done this all, we need to have the addition with using the number given, which is convert from the 1 2 3 4 octal, so that we store in, and then we add with the last data, means D1 that we have. So after done this all, then we can execute. Then there was end of the coding. So let me show the step by step for how the 68K will how to move lah. So first, after we run our code, as we can see that it will be all of the number will be 0, and then nothing happen in this first line. So after that, we click this button. This button will be move to the next steps. So after we click it, the blue line will be from the first line, jump the line number 10, jump to line number 11. So in this case, it already done the instruction from the line number 10. So the data is already stored in the, as you can see, the data is stored in the D0. So the D0 become BF. Okay. After that, like we still need to click the button like just now. Here I didn't put in. So like as well, we need to click the button, and then after that, we will execute into the line 12. So now the line is reading the line 12. So the previous line, which is the line 11, the data is already stored in D1 as what we write here, the instruction of our coding. So now the data is stored in D0 and D1. So both of them are stored. So now move to this 12. So now we need to do our multiplication with this mulu instruction. So as well, we need to click the button to the next steps. And after that, here will become the line 13, and then the instruction of line 12 is already done. So the multiplication is the D0 and multiply the D1, and then the data will be stored in D1. So now you can see the data from the D1 is already changed. Like previously we have the data, so it will be these store this value stored in the D1. So the value of A348A6 is the product of the multiplication, so it will store in D1. After that, we keep looking at the next step, which is 14 is nothing. The 13 steps, yeah, now it's reading the 13 steps. And after that, we click this button as well, so it will be done, execute the line 13. Okay, so move to, after we click it, it will jump into the line 15 because the line 14 is empty. So now that's already all done for the things. The difference that occur is like the D1 already changed like before. Here is 848A6, here will be 4B42. Like why? Because like our line 13, like we need to add the 29C into the D1. So like this value is convert from the 1 to 3 octal. So now we added this value into the D1. So the D1 is already changed. So this will be the D0 and D1 will be the last data that's stored in the register lah. So after that we have no any more instructions, so here will be the final. So after that, this things is the end of the coding, so it will be totally end, so it won't have any instruction next. So after my explanation, that's all from my part. Thank you for all.